Hey guys, welcome back. Today we are going to discuss about the integrity constraints. A constraint is a property that is assigned to a column or to a set of columns in a table that prevents inconsistent data being placed in the table columns. Constraints are used to enforce the data integrity and hence they ensure the accuracy and the reliability of the data in the database. There are various types of integrity constraints which are Oracle supports, and they are primary key, unique key, foreign key, not null, check, and default. Let's discuss them one by one. So the first constraint in the list is primary key. A primary key constraint is a unique identifier for each record in a table. Every table should have a primary key constraint to uniquely identify each row in our database table. A table can have only one primary constraint and it cannot be null. Let us look at the syntax of creating the primary key constraint. So we can assign the primary key constraint at the time of table creation, either at column level or at table level. So let's look at the syntax to implement primary key constraint at column level. So while we create our database table, we can assign this constraint. So we have a syntax create table, table name, and then we can assign the column names, data types, and their corresponding size. And also we can assign our constraint to a particular column which we want to be a primary key. So to assign the constraint, we have a syntax constraint, constraint name, and then primary key. Similarly, we can assign the primary key constraint at table level also. So once we declare all our columns which are required for our table, at last we can just go and assign this as constraint, constraint name, and then primary key. Inside the braces, we need to provide the column names which we want to be the primary key of that table. Let's look at some of the examples to understand this primary key constraint in detail. So here we are creating one table called employee, and then inside the braces we are defining the columns which are required for our employee table. So in this table we want our employee number to be the primary key of our table, and hence we have simply kept this primary key keyword in front of this employee number column. So let's go ahead and run this job. So we have got the log as table employee has created. So as we know, whatever the column we are defining as primary key, it cannot have null values, as well as it cannot contain the duplicates. So let's go ahead and insert some records and see if the primary key constraint is working or not. So here I am inserting two records with the name Smith and Lillian, and their employee numbers are 7369 and 7499. So we have inserted these two records in our table. Let's look at our table after inserting those two records. So these two records are there in our table. Now let's try to insert one more record with employee ID 7499. So we have another insert statement where the employee ID or the employee number, sorry about this, is same which is already inserted in our table. So if the primary key constraint is working in our employee table, this particular record should not be inserted and we should get some error. So if we run this query, you see here we are getting an error saying that unique constraint violated, because we are trying to insert this same employee number again in our employee table, which is already present. Let's do another check whether primary key constraint accepts the null value or not. So for this, instead of this employee number, let's make it null and run this query. So if you see here, since we have applied primary key on our employee number column, it is saying cannot insert null into employee dot employee number. That's the column where the primary key is defined. So this is how primary key constraint work. So this constraint we have defined here is at the column level. So please remember, when we have to implement primary key constraint on a single column, we can implement it at column level. But if we want to implement primary key on more than one columns, then we need to implement this constraint at table level. So here we have created another DDL for the same table creation, which is employee, with same number of columns, but this time we want this primary key to be implemented on employee number as well as on department number columns. So let's go ahead and run this query. So table employee has been created. Now let's try to insert those records again. So these two records has been inserted. Let's look at them in our table. So they are available. Now let's try to insert another record with same employee number, which is 7499. Let's run this query. This time, please notice The primary key is a combination of employee number and department number. Hence, we need to pass 7499 and department number 30, which is already there in our table, to check the primary key constraints or the violations. Okay, so let's run this query, and if you see, we have got the error saying unique constraints violated. Okay, because we are trying to insert the same employee number 7499 and department number 30 once again, which is already there in our table. Also, please remember, when we have a primary key with combinations of more than one column, these columns together make a key which is called as composite key. Okay, let's move on to the second constraint in the list, which is foreign key constraint. A foreign key is a column or set of columns in a table that refers to the primary key of another table. The table with foreign key is called the child table, whereas the table with primary key is called a parent table. It will prevent any action that would destroy the link between parent and child table with the corresponding data values. Let's look at the syntax of foreign key implementation. Like the primary key constraint, we can also implement foreign key constraint at column level as well as at table level. So to implement the foreign key constraint at column level, we have a syntax create table table name, and then we have column name. Then we can simply implement the foreign key constraint to any column of our choice, saying constraint followed by the constraint name, and then we have a keyword called foreign key references the parent table name from where it is referencing the columns, and then inside the braces we have column names. So please remember, whenever we are implementing the constraints at column level, we can implement at any one column at a time. And let's look at the syntax of table level as well. So to implement the foreign key at table level, we have a syntax where create table table name, and then we will define all the columns which are required to create our table, and at last we can define our foreign key constraints with the keyword constraint followed by the constraint name, and then again foreign key whichever we want to define as a foreign key in our table, and then references parent table column names. Let's look at the example of implementing the foreign key in real time. So in the last lecture, we have created a table called employee and inserted two records. Let's look at that table once. So here are these two records, and we know the primary key for this employee table was employee number, right? So let's go ahead and create a child table which will reference the columns from our employee table. So here we have a DDL to create a table department with four columns: employee number, department number, department name, location. And here we have implemented the foreign key constraint at table level. So we are saying foreign key, the column name, which we want to make as a foreign key in our department table, which is employee number, and then keyword references the parent table name, which is employee, and from this parent table we are referencing the column employee number. Okay, so let's go ahead and run the query. So the table department has been created. Let's look at the data inside it. So this table is empty for now. Let's insert some records. So here we are trying to insert 3 records. Now let's look at the data. So we have these 3 records available in our department table. Please notice here, we have tried to insert the duplicate employee numbers in our department table, and it has allowed us to insert those duplicates in the employee number column. So you must be having a question in your mind how the duplicates are allowed. So please notice we have not defined any primary key constraint on department table. If you look at the DDL here, we have not defined any primary key constraint over this employee number column. We are just referencing the employee number column from our employee table. Okay, so that is why it has allowed us to insert these 2 duplicates records. Now let's try to delete the records from our employee table. So just say delete from employee. So since this is a parent table, let's see if it allows us to delete the records from employee table. If you look at the log, it says integrity constraint violated, child record found. Okay, so you cannot delete the records of the parent table if they are existing in the child table, which is referencing that parent table. Okay, so in our case, the employee number 7499 and 7369 are there in our department table, and hence it is not allowing us to delete the records from our employee table, which is acting as a parent table. Okay, if we want to delete our parent table records without getting this integrity constraint violation, we can use on delete cascade keyword while creating the child table. In that case, if you delete the parent table data, the child table data will automatically be deleted. Okay, so let's implement that on delete cascade keyword and recreate our department table. So here we have the DDL which we have used earlier to create our department table, which is a child table. Now let's use that keyword on delete cascade and recreate this table. So if you see, department table has been created once again. Now let's go ahead and insert those records which we have inserted earlier. So we have three records in our department table: 7499, 7499, 7369. These are the three employees we have in our department table. Let's look at this employee table also. Now try to delete the record from our employee table where employee number is equal to 7499. So one row has been deleted from our employee table. Now let's see what is there in our department table now. So if you notice here, those two records with employee number 7499 has automatically been deleted when we have deleted our parent table record. Okay, this is how on delete cascade works. The next constraint is unique key constraint. So this unique key constraint enforces the uniqueness of the value in a column or set of columns. So no duplicate values are allowed on the column where we have implemented our unique constraint. There may be more than one columns with unique key constraint in our table, and also it accepts the null values, which was not the case with primary key. Let's look at the syntax of unique key. It is almost similar to the syntax of primary key constraint. So again, we can implement this unique key constraint at column level as well as at table level. So while implementing it at column level, we just have to say constraint, constraint name, and unique, which is the keyword. And when we define it at table level, we just need to say constraint, constraint name, unique, and the number of columns. Now let's switch to SQL Developer and see some examples of this unique key constraint. So here we have a DDL of our employee table with 6 columns, and we want to make employee number and department number as unique. Okay. So let's run this query and employee table has been created. Now let's insert these two records in our employee table. Records are inserted. Let's look at the data now. So here we have these two records. Now let's try to insert the record with same employee number 7499 and department number 30, which we have created as a unique key constraint for our table. So here we have the insertion query. Let's run this, and if you notice, we are getting an error unique key constraint violated. Okay, so you cannot insert the duplicate records when you're implementing a unique key constraint on your table. Now this time let's try to insert the null record. Let's make it null at employee number column as well as in department number column. So let's run this query, and if you notice here, the record has been inserted. Let's look at the data of our employee table now. You see this record has been inserted with null values on a unique key constraint columns. So that's the major difference between primary key and unique key. Unique key can accept the null values, whereas primary key does not. Moving on to the next integrity constraint, which is check. So the check constraint is used to limit the values that can be placed in a column. In other words, it basically checks the condition, and if the condition satisfies, it inserts the value. If the condition does not satisfy, it throws an error. So here is the syntax of check constraint. We create our table with all the required columns, and then at last we can use this check keyword, and inside the braces we can pass the condition. Let's create a table again with this check constraint. So here we have our DDL with check constraints, where we are checking department number should be greater than 10 and less than 100. If somebody tries to enter the department number which is not falling under this category, it will throw an error. So let's go ahead and create this employee table. And now let's try to insert a record with department number 200. So if we try to insert the record with department number 200, it will throw us an error. So the error is check constraint violated. The next constraint is not null constraints, which enforces the column not to accept the null values. And here is the syntax of not null. Just create table with table name, and we can define all the columns which is required for our table, and whichever the column we don't want to keep as null, we simply write a keyword not null right in front of that column. So let's switch to SQL Developer and try to see some examples. So here we are in our SQL Developer. I have again tried to create a same table called employee with same number of columns, but this time I have given a keyword not null to employee number column. So let's create this employee table, and try to insert the null values in the employee number column. So here we have an insert query where we are trying to insert a record with null employee number. So let's go ahead and run this query. So we are getting an error, cannot insert null into employee.employee number column. Okay, that is how we implement not null constraint in our tables. The last constraint in the list is default constraint, which inserts the default value in a column if we are not inserting the value for that particular column explicitly. So here is the syntax of using this default key constraint. So simply create your table with all the required columns, and whichever the column you want to keep with default value, you just have to use the keyword default along with the value which you want to. Now let's move on to SQL Developer and try to implement this default key constraint. So here we have the DDL for employee table, and we are defaulting our salary column with value 20,000. So if we do not insert the value explicitly as part of our insert statement, the default value for salary column will be 20,000. So let's go ahead and create this employee table again. Now let's insert one record where we have a salary. So we have a record with 7369 employee number and the salary is 90,000. So one record has been inserted. Let's commit this change to make it permanent. Now let's see what is the data there in our employee table. So if you notice here, we have one record with salary 90,000 which we have explicitly inserted. Now let's insert another record with no salary. So this time we are not inserting any salary. So the insertion has been completed. Let's commit the change again, and this time see what is the value has been inserted in the salary column. So even though we have not given the explicit value for salary column, it has taken the default value which is 20,000. So that is how we use default key constraint. We can also implement these constraints using alter table command, but make sure the already existing data should not violate the constraint. If already existing data is violating the constraint, it will not allow us to add that constraint as part of alter table. So with this, we have covered all the constraints which Oracle supports. That's it for today. We'll see you in the next one. Thank you.